Professor Bialis here. In this video we're going to be talking about section 10.4 where we add, subtract, and multiply radicals. Adding and subtracting are pretty much the same thing, and then multiplying is going to be its own situation. Let's start with adding and subtracting. Now when we add and subtract radicals, it's going to be the same thing as when we are combining like terms. For instance, if let's say I give you 3x plus 5x. You probably wouldn't even bat an eye at that and say, well, 3x plus 5x is 8x. No big deal. It's going to work the exact same way as if I said 3 square root of 2 plus 5 square root of 2. That's simply going to be 8 square root of 2. Nothing more than that. Okay? So basically, adding and subtracting radicals is going to work the same way as when we were combining like terms. Okay? There's going to be a little bit more that we can do to make things come together, but when it comes to actually adding and subtracting, just pull together the like radicals. Nothing more than that. Okay, so let's say we have something like this. Say something like that. Okay. Now, in this case, not only do the variables have to match, the whole radical part of the expression has to match. So square root of 3y, square root of 3y, they're good. All we do, 5 minus 2 is 3, and we carry that square root of 3y. End of story. Nothing more to it than that. Okay. Now, the tricky part comes into something like this. Now, square root of 50 plus 5 times the square root of 18. At first glance, you look at that and say, well, those aren't the same, so we can't do anything with it, just leave it. That's like saying x plus y, okay? However, can we do something with those radicals? When it's a variable, x is x, y is y. But with a radical, 50 can be thought of as 25 times 2. That changes things now, because we can simplify the radical to read square root of 25 is 5, square root of 2 is square root of 2. What about that 18? 18 is a 9 times 2, square root of 9 is 3, and then square root of 2. Now don't forget, we still have this 5 sitting out in front. So 5 times 3 is 15 root 2. Okay, one more time. 18 is 9 times 2. We picked 9 because it's a perfect square. Square root of 9 is 3. This 5 came down, and square root of 2 is still just square root of 2. And now, looking at this, they match. We couldn't do that with variables. Here we can. Now, what's 5 root 2 plus 15 root 2? 20 root 2. Notice I didn't touch that square root of 2. I just carried it along like a label. Okay? Let's look at a few more of these. Okay, so we're subtracting and adding, none of these match. But they do, or they can be simplified, so let's do that. So, cube roots now, not perfect squares, but perfect cubes. 24 is going to be 8 times 3. Again, 8 is a perfect cube. So that changes to 2, cube root of 8 is 2, times the cube root of 3. Now, 192, we have to look at that. Okay, 192, start taking through or going through all of those perfect cubes. And guys, if that means you need to pick up your calculator to do it, then you do it. Okay, so if I was using the calculator, for instance, and let's say I don't have the perfect cubes memorized, I would plug in 2 cubed is 8. Okay, then 192 divided by 8, enter. That gives me a 24. That's all I would do. I would cube a 2, then divide this by that perfect cube. If that didn't work, I'd go 3 cubed, 27. Does 27 go into that? And so on. So I get 8 times 24. Now don't stop there. Okay? I picked 8, but 24, there's another perfect cube that goes into there. I can break that up into another 8 times 3. Okay? So watch how this is going to come out. I have the 4 coming down, but then I have this 8, the cube root of 8 is 2, cube root of that other 8 is 2, and then I have the cube root of 3. Okay, I still need to multiply those together, but that's where it all falls out. So 192 is an 8 times 8 times 3. Or I could have thought of that as a 64 times 3. And then I get cube root of 3 over here. So that's 2 cube root of 3 minus 4 times 2 is 8. 8 times 2 is 16 cube root of 3 plus cube root of 3. Now they're all cube roots of 3. I have 2 minus 16 is negative 14 plus, there's an understood 1 there. So negative 14 plus 1 is negative 13 cube root of 3. And there we have it. Okay, so again, in this case, I took the 8 first because I was just plugging in the calculator. Okay, if I kept going, I would have found 64 is a perfect cube, 64 times 3. Okay, but again, taking the 8 out didn't really, make a lot of extra work or anything like that. Once you find a number, take it out. Don't worry about trying to find some bigger number. You'll be able to get it later on. Okay, let's keep going. Let's look at this. Now, again, first thing we always want to do, simplify if we can, because then that sometimes shows terms that we otherwise would not be pulling together, and it shows them as the same. Okay, so simplifying these, a 20, we're talking about square roots again, is going to be 4 times 5. Square root of 4 is 2, and then I keep the square root of 5x. Okay, this next one, 16 comes out nicely. So I still have that 6 there, but the square root of 16 is a 4. So what I get is a negative 24 square root of x. Okay, there's no other numerical coefficient left in that radical. It's just that x. And then 45, I'm going to think of as a 9 times 5. So that square root of 9 is 3 square root of 5x. Okay, now, do all these just add up together? In this case, no. Again, they all have x's, but the whole radical has to match. So these two terms are like terms. But then that middle term stands on its own. So what we have is 2 plus 3 is 5 square root of 5x. And then we bring down minus 24 root x. And that's the best we got. Okay, so be careful. The first few examples, everything just, piled into one spot. But that doesn't always happen. And if it doesn't happen, that's okay. I would definitely make sure, like if let's say you're done with a test and you want to go back, I would check something like this to make sure you didn't miss anything. Forgot to write down a 5, for instance. But it is okay. Sometimes this does happen. Okay, so just be careful and aware of that. Okay, how about this? Now, what do we notice about this one right off the bat? These indices do not match. So that means there's no way we are going to be able to pull these together in the very end. However, it still would be incorrect if you left this, because as always, we want to have a simplified answer. So even though we look at it and we're like, these are not going to come together nicely because of those different indices, we still want to try and reduce them, okay? So a fourth root of 32, okay, that doesn't come out nicely, but let's think of fourth powers. Let's think of 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is a perfect fourth power, and I can pull that out. So the fourth root of 16 is a 2, and then I still have fourth root of 2. Okay? Again, did I have the 16 memorized? No. I just thought 2 times 2 times 2 times 2, 16. 16 works. If that didn't work, I would go to 3 times 3 times 3 times 3. And I would continue on that path until I found something that worked. Okay? Or if I got a number that was too big. 3 to the fourth is 81 already. So already that would have been too big. Now let's go here. 32. Now here's the tricky part. 32 in a square root is also going to be broken up into a 16 times 2. However, when we take the square root of that 16, we are going to pull out a 4 instead of the 2. Okay? So square root of 16 is a 4. Fourth root of 16 is just a 2. So be careful with like 16, 64. Those numbers are perfect squares, cubes, fourth powers, and so on. So they pop up in a couple different places. So be very careful of the index you're working with. And that right there is your final answer. There's nothing else we can do with that. Okay? The radicands match, but the indices do not, so they do not come together. How about something like this? Now this gets a little bit more complicated because we have to make sure radicals match, but we also have to follow fraction rules, okay? In order to add or subtract fractions, we need to have denominators match as well. So we're looking for like radicals, we're looking for common denominators at the same time. So first thing I would do is always simplify those radicals if you can. 75, I'm going to think of as a perfect square of 25 times 3. That's going to give me a 5 times the square root of 3, because square root of 25 comes out as a 5. Over 9 minus square root of 3 over 2. So what's nice there is we see the square roots of 3 match, but those denominators need to match too. So what would be the LCD in this case? Between a 9 and a 2, I would be using 18. So I'm going to try to make both of these fractions have a denominator of 18. How do I make that happen? I multiply this one by 2 and this one by 9. Okay? Now here, I have 2 times 5 times root 3. So all I do is a 2 times 5, which is 10 root 3. Okay? Outer parts multiply with outer parts, inner parts would multiply with inner parts. We're going to talk about that in a little bit more detail in a couple minutes. And then here I simply have 9 root 3. 9 root 3 means 9 times root 3. Just like a 3x would be 3 times x. Okay, now that those denominators match, I can just add, or in this case subtract, across those numerators. 10 minus 9 is just a 1 root 3 over 18. I cannot reduce 3 and 18 because it's not truly a 3. It's a square root of 3. And that's the best we got. Okay? So I simplify the radical, then I work with the fraction, making those denominators match. And then it's just adding across the top. Same as always. Okay? Let's look at one more like this. Okay? So first of all, let's clean up any radicals that we can. That fraction that we have at the beginning, remember what I say about the fractions. I want to keep that one big radical if the fraction itself is reducible. In this case, it's not. So it'll be better for me to use that quotient rule and separate those two radicals that are into two radicals. So I would have a cube root of 5x over cube root of 27 plus 4 times the cube root of 5x. Okay? Now, what's nice about that is, what is the cube root of 27? That comes out nicely as just a 3. So I have cube root of 5x over 3 plus 4 times the cube root of 5x. Okay? Now remember, we're adding two fractions here. If that means you have to put the 1 there, put it there. We need a common denominator. So I need this and this to both be thirds. The first one's good to go. And then the second one, I need to multiply by 3. Now when I multiply that by 3, I'm really doing 4 times 3, which is 12, and then cube root of 5x. Since those denominators match and those radicals match, I can just pull those together. I have 1 cube root of 5x and 12 cube root of 5x. 1 plus 12 is 13 cube root 5x over 3. And that's all there is to it. Okay? Again, if I could reduce this, I would, but in this case I can't. So that's the best we got. Okay, that's adding and subtracting. Again, it all comes down to simplify and then combine like terms. Okay, what we're going to finish with here is multiplying, which brings back that whole idea of a product rule with radicals. Okay, so let's just jump right into some examples here. Let's say we have square root of 2 times the quantity 6 plus the square root of 10. Okay. Now, as you're probably thinking, we are going to be distributing in this problem. The thing that I want you to remember here is that if you have a number inside a radical and a number outside of a radical, just put them together. Just put them next to each other. If you have a number outside and outside, you multiply. A number inside, you multiply. Okay? So it's just regular multiplication, but we have to pay attention to what goes with what. So as I'm multiplying square root of 2 times 6, I can't carry that out. All I can do is say 6 times the square root of 2. It's like saying x times 6, 6x. But now here we have that product rule that says when we multiply radicals, we can multiply the radicands. So this turns into 2 times 10, or the square root of 20. Okay, so again, this is inside, this is outside. I didn't really mesh those. I just put them next to each other. This is inside, those go together. Okay? Now, I don't stop there, because once I do the multiplication part, I can always try and simplify. So I'm going to have 6 root 2, and then this is a 4 times a 5. So 2 root 5. And there we go. Okay? Always think of simplifying at the end of this process. Let's look at a couple more. Okay, so again, as you're probably thinking, we are going to be distributing this, or you might say FOIL. So when we do that, I just have to keep track of what's inside, what's outside. root 3 times root 2, both inside, so I just get square root of 6. Root 3 times 7, 7 root 3. Now careful, I have a negative times a positive, so I'm going to have a negative term. And then root 5 and root 2 is root 10. And then negative times positive is a negative, 7 root 5. Okay. Now once I do the multiplication, I look to see if I can simplify any of these. In this case I can't. But also remember, I have addition and subtraction. Do any of them match? In this case, no. So always think, can I simplify? Can I combine those terms? In this case, I couldn't do either, but if it's there, make sure you carry that out. So this would be your final answer to that product. Nothing more than that. How about something like this? Now I want you to pay very close attention to the outcome of this problem because that's going to be very important for the next section that we talk about. Okay, so when we do this foiling, okay, how does that work out? Square root of 5 times square root of 5. Okay, square root of 5 times square root of 5 is a square root of 25y squared. Okay, some of you may be looking at that kind of funny. We're going to talk about that a little bit more detail in a second. Positive times negative is a negative 2 square root of 5y. Positive times positive is positive 2 square root of 5y. And positive times negative is a negative 4. Okay? Now, watch what happens. These two terms in the middle are opposites of each other. They completely cancel out. The other thing to notice is that first term, that 25y squared, that's a perfect square. That just comes out as 5y and then a minus 4. And there we go. Okay? So one thing I want you to notice, this original problem had the same two terms. Here you add them, here you subtract them. When that happens, all those radicals are going to go away. Okay, we're going to revisit that idea in the next section. Okay, so when you have same two terms, adding them, subtracting them, radicals go away. Okay, the other thing about this first term I want to point out, when you're dealing with square roots, I'm only talking about square roots here. If you have a square root times the same square root, you just drop out the radicand. Square root of 5y times square root of 5y is 5y. Square root of 3 times square root of 3, 3. Square root of 15 times square root of 15, 15. Square root of anything times that square root of the same thing, I just drop out that radicand. That will work every single time. Okay? Let's do one more example. Let's say we have something like this. Okay, now it's very tempting, especially since you have square roots and squares, you just put that square on there. But think of this like a polynomial. When you have multiple terms that are squared or cubed, you need to write them out. So the first thing I would do here is write this out twice. Notice I didn't change it, I just copied it twice. And now I go through the foiling again. Now, this is going to come out differently because I don't have the plus and then the minus. They're both minus in this case. Okay? Now, this will hold true though. Square root of 3 times square root of 3? 3. You can write square root of 9, but it's going to be 3. Then square root of 3 times negative 7 is negative 7 root 3. Negative 7 times square root of 3 is negative 7 square root of 3. Negative 7 times negative 7 is positive 49. Now, the radicals don't go away in this case, but a lot of this will combine. 3 plus 49 is 52. Then negative 7 root 3 minus 7 root 3 is negative 14 root 3. All I did there was combine like terms. And there we have it. Okay, and that is pretty much it. Okay, so we are adding, subtracting, and multiplying in this section. Adding and subtracting, you need to simplify first, but then it comes down to combining like terms. Multiplying, all we're doing is multiplying. Outside with outside, inside with inside, nothing more to it than that. Okay, so be careful with your arithmetic, and as always, work hard. Let me know if you have any questions, and I'll see you next time.